So, Professor Hanan Samet, it's a pleasure to meet you here in Sardinia. Also, why are you in Sardinia? Can you explain us?
Well, I came to give a series of lectures and under the auspices of the ACM Distinguished Speaker Program, and I'm also familiar with the work of Enrico Gobbetti, which is of great interest to me. So this is a two-pronged visit, one to give the lectures, but also to see the research results of the leading group in visualization that is in his organization.
It's the first time you visit CRS4?
Yes.
And which is your feeling about our center and the visualization group in particular and their job?
I was very impressed by the results and the connection to practical applications. For example, yesterday I went to the museum and saw some of the results of their work being applied to show people who visit the museum every day to help them interpret the results.
So you are a well-known expert of spatial structures, and they can be seen as a particular type of multidimensional data sets. Why are multidimensional databases so important nowadays, even in comparison with traditional relational databases?
Well, the relational databases can be used to implement multidimensional databases, but the real importance is that we have location pervading everything we do, and this is really because of the smartphone that we all have. And since it's easy to put a GPS device in the smartphone, we have information that's being sent, but your location is also being sent, whether you agree to it or not. And these are really privacy issues, but that's another field which is beyond the scope of my visit.
So which are nowadays the most popular application of multidimensional and metric data structures?
It's used a lot in similarity searching, and for example finding nearest neighbors. We use that in machine learning and other applications, that at the end you're really looking for who is similar to you. And what these data structures do is they enable you to sort the data, where you're sorting not in the traditional way of finding and ordering, but really finding a differentiation, because we can really sort only in one dimension, and by that I mean obtain an ordering. Otherwise the orderings are really linearizations, which are really mappings from high dimensions to one dimension. So what we do is try to sort in the original dimension, which is really a process of differentiation, not necessarily an ordering.
So today computer graphics plays a major role in science, engineering, education, multimedia, medicine, and so on. And this is generally done at the expense of a strong computational effort, because computational graphics is very demanding from the point of view of CPU time and memory allocation and so on. So which are the most challenging problems for computer graphics today, and why hierarchical spatial representation is so important?
Well, it turns out that the applications invariably involve search, and the way you speed up search is by organizing the data, and it's usually done by sorting. So if you look at the key questions in most computer graphics algorithms, usually you're answering the questions of what and where. Given a location, what is there, or given a feature, where is it? And of course, we don't necessarily realize that this is what we're doing, but most questions really boil down to that.
In your book, famous book, you show that there are a plethora of methods for sorting spatial data. For instance, those based on space decomposition, there are those based on minimum bounding rectangles or disjoint cells, so different families of methods. Say that it is a crowded zoo. Why so many methods, and how one can choose the most suitable methods for his own application?
Well, what I like to say is that there are really just two principal methods. One is based on an object hierarchy, the other one based on an image hierarchy. And what happens is that people don't realize that their methods are similar, that they're from the same families, and people just don't look so much at what other people do. And the other aspect is that the problems arise in so many different fields, and different people try to solve them. And what I tried to show is the similarity of the methods, but yes, there are different techniques, but they're very much related.
So we see that methods originally proposed 40 years ago, like for instance quad trees, are still actual, at least when computational time optimization is an issue. So is that surprising for you?
Not really. What happened is that the applications have developed and the methods were there. So, for example, in games, video games, and these applications, location-based services, everybody's using them. Before, there were just a few people who were doing image processing, or how many people were doing visualizations. Not many. But today, with everybody having a smartphone, a portable computing device, it's just part of the data. And since location is just part of everything we do, it's not surprising. Before, we looked up some information, okay? Since almost everything we do has something to do with location, so location is a good way to index data, to look things up. So if I go to a place, I give you a location, you'd like to know everything about it. And the talk yesterday was about the spatial synonyms. I didn't have to know exactly what I'm looking for, but instead, if I just go to the map and I put my finger there, I zoom or I pan or do these actions, I can specify a location and retrieve information. So the point is, it's very easy to retrieve information by location. Surely, location is just one aspect of all the information that you have, but it's one of the easiest ones to specify, especially if you don't know the location. Because if you don't know the location and you know where it is, you can go to the map with a touch device and put your finger there and zoom and do other things, and you get the locations presented to you, so you didn't have to know what they were before you asked the question. So this is what I call the spatial synonym. In other words, if you're looking for a rock concert in Manhattan and you find one in Harlem, that's a good answer because Harlem is in Manhattan. Or if you're looking for, or if you're getting an answer like Brooklyn, Brooklyn is a good answer also because it's a sibling borough of Manhattan. Or if you get an answer like New York City, it's not as precise as Manhattan, but still better than nothing because it contains Manhattan. So we see that location is one of the parameters that you're searching on that allows variability. that permits approximations. If you do a search on other attributes, you cannot use synonyms. You have to know exactly what you're looking for. If you cannot specify it exactly, the search engine won't get it for you. And what we're doing with location is we're no longer constrained to do the search in a box. We are all used to doing searches with search engines like Google and others where we type in a keyword. Well, if you don't know the keyword, you can't get an answer. However, with location, you don't have to know the name of the location. You just have to know where it is. We often know where things are without knowing their names. So searching with location has this added attribute or convenience that makes it easier to find out information. And of course, when you do that, you have to index the information so that you can retrieve it quickly, and spatial data structures help you in this respect.
So, and in fact, in the course of the last 30 years, you and co-workers have developed a news stand, an application for enabling people to search for information with a map query interface. Could you explain its main features?
Well, the main feature is that you go to the map and you move your finger around, you zoom if you want to get more precise locations, and you don't really have to know what you're looking for. In other words, you're going on the map and you're saying, well, some event happens somewhere. I go to the location and it tells me what events have happened there. The advantage is that if the event happens in several locations, then all of the locations show that event. So the map query interface enables you to look for things using spatial synonyms, because as I mentioned before, if you don't know the full name of where something is happening, as you go to the map suggests to you, gives you answers of where things are happening. So if you start with a map, it shows you, let's say, icons of various places where events are happening. As you zoom in, unlike a mashup, you get more data. Most people are used to maps that are mashups where you put push pins on where things are happening. But if you zoom in, you're only getting closer on the map. You're not getting more information. So what we do is we present a certain amount of information for the map. Then as you zoom in, you're homing in on an area, you get more information, more topics. In other words, things that may not have been so important when you look at the word globally, but if you zoom into Sardinia, there are events that are happening of interest to people in Sardinia which are not of interest to people elsewhere. So they don't show up elsewhere because nobody's really talking about them elsewhere except in Sardinia or in these areas. So it's a way of localizing the information, or filtering, enable you to prune and get what you want without knowing that you're looking for it. This is what I think the key principle or the key advantage is, finding things that you're not looking for.
So say that the idea behind the news stand is to make map the media of choice.
Exactly.
It's an idea which can be extended to documents other than news. For instance, you made a Twitter stand for tweets. And so which are the most promising development in the field, in this field for the near future, in your view?
Well, I think you can get more and more information, with spatial attributes, and what we showed was you can retrieve photos by location, we can retrieve tweets. In fact, for any topic for which you have an ontology, you could retrieve things with a map interface. For example, what I find really attractive is using the spatial temporal property. In other words, looking for events over time. One of the things we're able to do is trace the movement of a disease by looking at where it's discussed. So if you have information about, where, like Ebola, you have news. If Ebola is happening, you have news articles about Ebola, and if you keep track of them over the years, you could trace the spread of the disease by seeing where it's being discussed. Okay. Another example that we already do is in brand remediation. Companies always want to know what are people saying about them, and location is very important because when they target their expenses and how to remediate bad publicity, there's no point in spending a lot of money on advertising in Antarctica where you might need it in New York City or something like that. So this provides a nice overview of where the company is being discussed. In fact, this is not new. Companies have been subscribing to clipping services for years. These are organizations that sit and read every newspaper and write down which company is being mentioned. Another useful application is in our embassies. Most of the people who work in embassies, they're reading local newspapers to find out what is important to report back to their countries, their home countries. An application like Newsstand or a MapQueer interface can speed that up so that the information is available to higher ups, doesn't have to go all the way at the bottom level, and can be done without human intervention. That's the real goal.
Suggestive idea is the attempt to mine future spatio-temporal events from news articles, for instance, at a specific geographic location. Could you say more about this topic?
This is a good question because I mentioned before in disease tracking, we're looking at past events to see how the disease is moving and also trying to predict where else it can go. The spatial patterns are very useful for that. So that brings us to a much more general topic, which is trying to identify events that have occurred and also mentions of future events to alert people that things are happening. Many times events are discussed, yet others have no idea that they're going to happen. And so mining for the news, not just for the present, but for the past and future, has very important ramifications. For example, in public safety or disaster, emergency management, emergency response. Emergency responders could use as much information about where a possible future hurricane or future event might happen. So this is a natural tendency or direction for this work to proceed, which will be of huge public benefit, societal benefit.
Go on to work on this topic?
Well, a lot of my work depends on if I can find students who are interested. As I say, you can lead a horse to water, but you can't make him drink. And this is a problem in research, is you may have good ideas, but you also have to lead others to follow you. And our society values independence of individuals in terms of deciding what to do, and we can't really force them to undertake certain research. Hopefully, by publishing articles and giving talks, we broaden the potential of people who might be interested to conduct further aspects of this research.
But it seems that you succeeded in providing a sort of link between academy and say companies.
Well, we haven't really worked with any companies on this. I think that they often take a shorter view of what can be done. And also we have this big elephant in the room called Google, and everybody thinks that Google has solved search or has done all possible search. And I don't think that Google necessarily believes that they've solved all problems, but many people think that search is a done, field solved. And I think there are many interesting topics in search to be pursued.